When you get bored, and it seems that nothing can surprise you anymore, just look up at the sky. The universe is so vast and mysterious that it is full of things that can't be explained except by magic. How about the most ordinary star with another neutron star lurking inside? Or a planet orbiting the deadliest object in the universe? Make yourselves comfortable, friends. We are about to embark on a journey through the true wonders of our universe. Like the story of most inventions and discoveries, the story of our first miracle began on a piece of paper. In 1932, Lev Landau hypothesized the existence of neutron stars. It is ironic that Landau's prediction happened before the discovery of the neutron itself. Nevertheless, the scientists suggested that gravitational influence could compress stars, so that the density of matter would become so enormous that the nuclei of trillions of atoms would fuse to form one. A neutron star is really an object whose density is greater than the density of the nucleus of an atom. If you poured neutron star matter into your tea instead of water, your mug would weigh more than Mount Everest. There are, of course, hypothetical quark stars, but so far the situation in physics is that only black holes are denser than neutron stars. In the total mass of a neutron star is an object with the mass of the Sun, only the size of a couple of tens of kilometers. There are a lot of them in space, about 1 in 1,000 ordinary stars. Well, specifically we are interested in a curious case described by the same Lev Landau in 1938 in the journal Nature. The physicist suggested that there might be ordinary stars with neutron stars lurking inside. In 1977, Kip Thorne and Anna Zitkoff proved it mathematically. The theory allows mutant stars to appear in two cases. Either a neutron star will collide with an ordinary star, or the system will initially be double, and the neutron star will absorb the top of the ordinary star by gravity. They were called Landau-Thorne-Zitkoff objects. And after a couple of 3 erroneous candidates, they found a suitable one. The star HV 11417 in the small Mogilanova cloud shows anomalous signatures of ruthenium, molybdenum, and other heavy metals, which in such quantities in stars should not be. Scientists speculate that this is precisely because inside the most ordinary star is actually hiding another neutron star. And even though it is not yet a confirmed fact, in 93 billion light-years of the observable universe is definitely objects Landau-Thorne-Zitkoff. The second phenomenon on our list would be the Hogue object. Arthur Hogue, American astronomer, in 1950, discovered an unusual nebula in the center of a bright orange ball, around which an almost perfect ring of blue matter. There's a gap between the two parts, so big that another galaxy is visible behind it. Now imagine the astronomers' faces when it was revealed that Arthur Hogue had discovered not a nebula, but a galaxy. Improved telescopes showed in great detail that the galaxy had old yellowish stars in the center and young blue stars in the second circle. Hogue's object was once the first ring-type galaxy. Since then, several more have been discovered, but there is still no such perfectly flat and perfect one. Even more interesting is the situation of the planet with the telling name PSRB 1257 plus 12. Only it has no analogs to this day. This is the third wonder on our list, because we're talking about a planet orbiting Pulsar. To be more precise, we're talking about 3 planets: Dragour, Poltergeist, and Fabater. Pulsar is the same neutron star we talked about earlier, but a highly magnetized and insanely rotating star with a powerful magnetic field. A pulsar is a source of constant and predictable radiation, which is why they were once thought to be beacons of alien civilizations. The fourth wonder on our list is a planet with the loud name Methusa. In many compilations, it can be found as another planet that orbits around a pulsar. This planet is about twice as massive as Jupiter and lives in the PSR 162026. So what makes Methusa unique? Well, the planet is, by some estimates, 12.7 billion years old. The planet is almost as old as the world. It formed with its star cluster, M4, a billion years after the Big Bang, and it still lives to this day, and in a very unusual system. There's no life on Methusa, of course, because of its proximity to the pulsar, but it's very remarkable in its own right. And so is the next guest on our list. But this time, it's not about matter, it's more about the absence of matter. The universe as a whole is like mush, and despite all the clusters of galaxies distancing the camera, we will constantly see the same evenly pattern. This is the main principle of cosmology, which, like any principle, has exceptions. It was found about 10 years ago, and they still can't decide on a name for it. Some use the term relict cold spot, some use the supervoid of Eridanus. But we prefer the name Great Void because the object in question is really a huge spherical ball, about 1.8 billion light-years in size. There are galaxies, star clusters, and planets, except that the density of matter in the cold spot is much lower than in any other part of the universe, and consequently, so is the temperature. Hence, the second name, because in search of explanations, scientists have not come to anything better than to explain such deviations in temperature and density of matter by the presence in this region of space, a huge void. It's called the Eridanus supervoid, or the Great Void. The next wonder on our list is the Firmy Bubbles. These are pictures of the Andromeda Galaxy or the Milky Way. We are used to them, but since 2010, we have to get used to other images because the Fermi telescope has detected huge spherical clouds. They stretch as much as 50,000 light-years on either side, and if they were visible, the Fermi bubbles would take up half the space in the night sky. Luckily for us, they're made up of hot plasma and its gamma rays, which are 1,000,000 times shorter than our eye can detect. But Fermi bubbles are out there, and an explanation of their origin could well win a Nobel Prize. At the moment, everything is traditionally written off to a black hole in the center of our galaxy, which ejects matter. Well, the last wonder in our selection is the incredible, huge, and crazy Wolf-Rayet stars. There are only 500 of them in the Milky Way. A Wolf-Rayet star is not a type of star, but rather a period in its life. They almost always already have nebulae of ejected matter around them. Almost always, they are bright and unstable, shimmering with all the colors of the rainbow and blowing stellar winds of incredible power. And then they explode, becoming either a neutron star or a black hole. The closest such star to us, Gamma Sails, is 800 light-years away. And yet it's still perfectly visible, even to the naked eye. Someday, a supernova will form there, which will be visible without special instruments. But it may be a few million years away. For you and me, that's an eternity. Of course, the cosmos knows how to surprise, and 93 billion light-years of the observable universe is a distance in which can fit all conceivable and unthinkable wonders allowed by mathematics. That's all for today.